Question 48 is asking us how many unique real solutions does the equation x squared plus 12x plus 36 equals 0 have? The simple answer is 1. Why? Because the discriminant is equal to 0. But let's work our way to that. So when it asks us for the number of unique real solutions, immediately we should look to the discriminant, which is part of the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Now, you might be wondering what a, b, and c are. So I've written that out for you. The standard form of a quadratic equation is ax squared plus bx plus c. So in this case, if we look at the equation that we are given, a is equal to 1, b is equal to 12, and c is equal to 36. So let's substitute a, b, and c into the equation. And so if we simplify, then we get and so in the radical, we have 144 minus 144, and that's simply equal to 0. So now we don't have to solve this any further because it's asking for unique real solutions. So now we need to know how to find unique real solution from what we have. And for that, we look at the discriminant. The discriminant is b squared minus 4ac, and that's part of the quadratic equation. So what the discriminant tells us is if there are two real solutions, one real solution, or two imaginary solutions. How it tells us this is because of the radical. So let me show you. If b squared minus 4ac is positive, then that means there are two real solutions. This is because if we look at our quadratic formula, if b squared minus 4ac is positive, then you can take the square root of that. And because of the plus or minus, that allows us to have two different answers, two different roots to the quadratic equation. If b squared minus 4ac is equal to 0, then there is one real solution. Why is this? That is because in the quadratic equation, if this radical is equal to 0, then the plus or minus doesn't matter anymore because it's only what negative b is. Negative b over 2a would be the only 0 of the quadratic equation. If b squared minus 4ac was negative, then there will be 0 real solutions, but 2 imaginary solutions. And that's a completely different topic because imaginary solutions have to do with the imaginary numbers and I. But all you need to know is that there are 0 real solutions if the discriminant is negative. Back in our problem, we got the discriminant as 0. So based on what we just talked about, there should only be one real solution.